solve Zj minus Cj in the previous problem are greater than or equal to 0, then there exists an optimal solution to the auxiliary LTP. Fine. And also max Z star is equal to 0 and no artificial variable appears in the basis. In that case, we are supposed to go to the phase 2. So what happens in phase 2? In phase 2, so consider the final simplex table of phase 1 and consider actual cost associated with original variables. Whereas the next one is delete the artificial variable A1 column from the table as it is eliminated in phase 1. So now we are supposed to construct a new simplex table with original values. So the new simplex table will be like this. So it is CB followed by B followed by XB, then it is X1, then it is X2, X3, S1, S2. So I don't write any artificial variable because there was only one artificial variable, that is A1, which has been eliminated, which has been left the basis in the phase 1. In phase 2 we are supposed to eliminate it. So there are two rules in phase 2. So the first one is what? Consider the final simplex table of phase 1. What? And consider the actual cost associated with it in the original table and delete the artificial variable because it is already eliminated in the phase 1. That's why we have not included any artificial variable here. So let me write the values here. So let me draw the table. These are the actual cost, that is 5 minus 4, 3, 0 and 0. These are the actual cost. 5 minus 4, 3 and basis x2 followed by x1 and x1 taken from the final simplex table of the phase 1. So x2 is minus 4 coefficient, x1 is 0, whereas x1 coefficient is 5. Fine. For you minus 4 and 0. Fine. And xb is how much? I think xb is 30 by, xb is how much? xb is 30 by 7. So write down the values here. So let me write the values. So these are the previous values of the final simplex table of phase 1, but we are replacing with the original values of the objective function and removing the artificial variable column because it is already eliminated in the phase 1. So let me find the ZJ value here. So what is the ZJ value? So ZJ value is this into this plus this into this plus this into this. Fine. Whereas this into this, that is 5 into 1 plus 0 plus 0 it is. So answer is 5. Whereas this into this, that is 5 into minus 3 by 8 plus 0 plus 1 by 4 into minus 4. So answer is how much? That is, let me write 5 into 3 by 8 plus 0, then it is minus 1 by 4 into 4 it is. So this will get cancelled. That is 15 by 8 minus 1, that is 15 minus 8 divided by 8. Answer is 7 by 8. So let me write 7 by 8 here. Next one is 5 into 3 by 4 plus 0, then it is minus 4 into minus 15 by 6. Again let me write here, it is 5 into 3 by 4 plus 0 minus 4 into 15 by 6 minus 15 by 2. So how much it is? It is 15 by 4 here plus 0 minus minus plus 60 by 2. So that is 15 by 4 plus 30 by 1. So 15 plus 120 divided by 4. How much it is? 135 divided by 4. It is 135 divided by 4. Next one. This is 0. This is 0. This is 0. Whole thing is 0. So this is like 5 into 1 by 8, then 0, then 1 by 4 minus 4. That is 5 by 8 plus 0, then it is 1 by 4 into minus 4. This will get cancelled. That is 5 by 8 minus 1. It is 5 minus 8 divided by 8. How much it is? Minus 3 by 3. It is minus 3 by 3. So once we got the ZJ value, we are supposed to find the ZJ minus CJ. ZJ minus CJ is what? 5 minus 5. That is 0 here. Then it is 7 by 8 minus 4. How much it is? 7 by 8 minus 4 is equal to how much it is? It is 8, then it is 8, that is 32. How much it is? So 7 minus 32 is 25 divided by 8. How much it is? 25 divided by 8. Next, 135, it is 135 divided by 4 minus 3, it is So it is 135 minus 12 divided by 4. It is how much? 123 divided by 4. 123 divided by 4. This is 0 and I think this is minus 3 by 8. Fine. So what happens here? Since Zj minus Cj, it is 3 minus 8, we got 1 negative. After the first, after phase 2, we think that this LPP does not possess any feasible solution. So let me conclude here. So the given LPP, what? The given, since Cj all Cj that is equal to minus 3 by 8 is less than equal to 0. Therefore, the original LPP does not possess any feasible solution. Fine. So this is what two-phase simplex method. Fine.